Cool. So I'm glad you're here. I know the talk description was it gave a little bit away. It was a little bit vague. Part of that was because we did a three-month research sprint right before this. We put a bunch of topics up. We're like, hey, we're going to see how much we can get done. And then whatever we accomplished ended up in this presentation. So that's why we're a little vague at the start. But I think we put together a pretty fun presentation. I'm glad you're here. I think you're going to have a good time. So what you're going to see, first about me. Last year I gave a talk on a tool called LSA Whisperer. It was a tool that allowed you to get largely credentials from LSAS without touching LSAS memory, as well as some other neat tradecraft that was useful for red teams. This year we had set out a goal to do a similar thing, but with cloud tradecraft. So now background for me, I work at SpectreOps. I'm a systems developer. I develop desktop software for red teams. I work on a team called the Internal and Community Products team. We develop software that we use internally on our consultant team, but we also publish most of it, as much as we can, which is most of it, for the wider community to use as well. So some things you may have seen from our team is the Mythic C2 platform that my colleague Cody Thomas writes, as well as if you're into writing reports for clients, you may have seen the Ghostwriter report management software that my manager, Christopher Madalena, first started, and then my coworker, Alex, now maintains. There's a lot of other colleagues that I really appreciate at work, though. Basically, every person I work with at work, I love to talk with every day. But three in particular were very special with this research for me. Elad Shamir, Lee Chagoya Christensen, and then Will Schroeder. They're people that I just backboard ideas off of a lot. So if you see these three faces, one of them is in the back, Elad. And if you appreciate the work in this presentation, they really helped a lot, even if it was just like discussing ideas and coming up with things to do. So thank them, please. Now, there's people outside of this company as well that also helped. If you're one of these people, if you're here, or if you see this online later and you see your name, thank you. You may not have realized that you helped with this work, but you definitely did with the research that you put out. So everything you did, I do appreciate. Now, the description for this talk was a little vague. Here's what we're going to talk about. You're going to get a short story that is going to describe how we got here today. We're going to go over this thing that has helped really propel the project forward, a development kit that we made specifically for producing more features for this tool. But we think if you're a reverse engineer, you're going to get a lot of value from this development kit as well. Now, the main meat of the talk is going to be discussing this problem that that's been bothering us for about 2 years now in our own red teams, which is essentially this plethora of APIs on Windows for getting the token. A lot of red teams deal with cloud tradecraft. You need a token for that. Like, which API do I use? It's a pain in the ass a question, but we're going to attempt to answer that today. That's the main meat. And then if you stick around, there's a lot of internals we have to get through. But if you stick around to the end, there's a present for you if you're a red team operator. So if you're watching online later and you just want to skip to the end, that's totally okay as well. Okay, now the short story. We presented LSA Whisperer last year, which I've mentioned earlier. There was a lot of work that led up to it. I think it was like 2 years of just work that went into it. We fully intended to keep developing it. And in a large part we did, but which you're going to see today. But there was a time after SoCon where I just couldn't do it. It was the creativity and the drive to produce more features for this tool. It just dropped off a cliff. I talked with a friend of mine who has all these like Yoda sayings, and one of the things he told me when I was describing this to him, he said, you go through different seasons of your life if you're a creative person, and you might go through a season where this creativity and this drive just goes away. And that's okay. It's normal. Just be patient, wait, something might change. And that may come back. And if it doesn't, you may find something else. It's all okay. So if you are in a similar boat, I just want to share those seasons of your life. You might go through a withdrawal. That's fine. Things will change if you just be patient. Something happened. Around October last year, I was chatting with some coworkers, which I do every day. I love doing that, specifically with Lee Jagoya Christensen. And he said, hey, last night I was on this Discord channel, and they mentioned that someone seemed to put some private symbols for Windows on the Wayback Machine. And I was just like, this can't be true. If you've done any reverse engineering work, you may realize that there's source code leaks that have happened, but the last source code leaks that I'm aware of have been from NT versions 3.5 and NT 4 through 5.2, which is XP Service Pack 2. Those are old versions of Windows. Every now and then there's private symbols, but usually they're like really old private symbols. But what these guys were talking about were NT10 1607 for the x86 platform, and then 1703 for the ARM 64-bit platform, which you might think, ARM, who cares about that? But if you're a reverse engineer, you may realize it's a 64-bit operating system. I don't care that it's ARM. The structures align is just as good as like an AMD 64-bit processor in regards to reverse engineering. So he messaged me and I was like, this would be amazing, like a gold mine, but I just can't believe this would happen. I downloaded these symbols, checked them out. They're real. They're still online. I encourage you to download them yourself. I don't know why Microsoft distributed them to people. I think they were partners. That's my guess. I don't know why they were put on the Wayback Machine, but they were, and we're going to use them. For the x86 version, that was a workstation build. For the ARM 64-bit version, it strongly appears that it was a Server 2025 build, where they installed virtually every server role before they dumped the symbols. So you have like all this esoteric software that you normally wouldn't have access to the private symbols for, but they're on the Wayback Machine. So please go download these. Now, what did we do with this? If you haven't guessed, by the way, when I was in that lull of creativity, that was the thing that reinvigorated the excitement for this project. I was like, okay, there's all these types, everything that I was like, we had to reverse engineer as an industry are in these types. I don't have to guess anymore about structure offsets. We just have a roadmap. So the first thing we did is we started looking through this, comparing it to old source code leaks, comparing it to a lot of DLLs that were reverse engineering manually in Ghidra, like that never changes, and then dumping them out and then organizing them into different header files. And what we came up with was a development kit for the project. There's a lot of stuff in here. One of the main things is we have types for anything you can imagine to deal with LSA or related technologies. There's a lot in there. The next thing we added was RPC interfaces. We have a lot more planned, but the few that you see are for things that you're going to see in this talk. So you have stuff to do with essentially getting tokens or interacting with authentication packages. But again, we have more planned. We also added type serialization code for RPC as well as ASN1. So some people may be familiar that although RPC is mainly used for defining interfaces, APIs that you can talk with, another subcomponent of that is it can define type serializers, and you can use it solely for that if you want. And that comes up a lot in LSA technologies. So things like the pack for a Kerberos ticket, that's something that is, we use RPC serialization, at least Microsoft does, to serialize and deserialize the pack. So we added all those in as well. So we had this pretty neat development kit. And again, we have a lot more stuff planned. This isn't everything that's gonna, this isn't gonna be like a static thing. We're gonna keep adding stuff. But we wanted to apply it to a real operational problem that we've been having. And that brings us to the meat of the talk. We looked around and we thought, what is something that has been plaguing us for a while now? Almost every single one of our red team assessments now have some cloud-based component. And if you can't get that objective solved with browser tradecraft, you almost always end up having to acquire a token from a Windows host to access cloud-based resources. Now, if you're an operator, you probably have your own favorite tools for acquiring these tokens. They all use different APIs, but you may have had this question at some point, hey, there's these different APIs to get a token. Why are they different? Which one should I use? We've asked this question ourselves internally, and the image on the screen describes like our brain when trying to answer that question. You look at one API and you say, "Oh, it's in a DLL. Let me open the DLL in Ghidra. Where does it call out to?" And it's just this massive nest of the most complicated technologies that Microsoft have come up with. They just said, we're going to use that here in our cloud code. Like, gone are the ways of old simple C APIs or COM APIs. Now we have WinRT, which they just shove in everywhere, specifically with cloud code, are just like API on top of API on top of API, when it could have just been one layer. They stacked up 3 layers, and so it's this nest of painfulness. About once a month, we would have this question, and we would, I at least would like come back to this question like every single month when someone would ask it, and my brain would look like this, and then it would end up looking like this at different stages of grief. Thank God I haven't reached the depression stage, but every single other one, the denial, anger, bargaining, and acceptance with my own self for not being able to answer this. Very real feelings, because most other things you can answer for your operators and help them out, but this one thing is just, it seemed like this unsolvable problem. So this may not be an interesting question to you, but it very much is an interesting question to me. And this development kit just illuminated all the parts in Ghidra that just didn't make sense prior. And so we wanted to put in thoughtful effort to, at least with this one question, get a good answer. So the meat of this talk is a guide to the token APIs for Windows. And this is going to be something that's going to be helpful if you're a researcher or a red team operator. So if that's you, stick around. And if you aren't, hopefully it's interesting. So a lot of this has stayed sort of stable from Windows 10 and 11. It would seem like Microsoft was really trying to figure things out in 8, but when 10 came around, they set up some APIs and like, these are what we're going to base things off of. So one of the simplest things to describe is there's an authentication package they shoved into LSAS called the Cloud AP Authentication Package, and this supports allowing you to log on with a cloud-based account. So a personal Microsoft account, a Entra ID account, those type things. This package supports it. Now, this package facilitates that by having sub-plugins. So there's this plugin for Azure AD. I did not misname that. That is the plugin name. That supports Entra ID and ADFS accounts if you set that up as an admin. There's also a Microsoft account plugin, which supports Windows Live ID. So things like a work account, a school account, a Microsoft account. Those are all Windows Live ID accounts, which are shoved into this Microsoft account plugin. So you make a request to the Cloud AP package and say, hey, I need a token or a logon or whatever, and it just kind of like redirects your request as needed. Now, sometimes your laptop goes offline, so these user credentials need to be cached somewhere. There's a on the file system cache called the Cloud AP cache, which facilitates that. And we're going to go over all these different components in depth. This is just going to be a guide for the overall how things are designed. Okay. Aside from LSAS, you have this other thing that's incredibly valuable, the Microsoft Account Sign-In Assistant Service. I don't use that service name. What I usually refer to it as is the RPC interface of interest, which is the Windows Live ID RPC interface. This is the interface where if you pop open Word or PowerPoint and you log into your account, this is the interface that application ultimately will talk to facilitate getting a token for that application. Now it needs a cache as well, which we'll talk about in a minute. But one thing to note, it communicates specifically with the Microsoft account plugin for Cloud AP. The nomenclature for all this is if you get a token from a lot of services, they're usually just called a token. But if you get it from the Windows Live ID RPC interface, Microsoft has called it the proof of possession token. And so you'll see APIs to get a proof of possession token inside the Microsoft account plugin as well as this RPC interface. And they kind of communicate together to facilitate recovering those POP tokens. So if you do anything with POP tokens, just know that these two components are kind of tied together in a friendly relationship. Now again, your laptop goes offline. These creds need to be cached somewhere. The cache for the RPC interface is also on the file system. It's called the token broker cache, which we're going to go into later. Now, these are what I like to refer to as the first layer APIs for getting a token. Microsoft took this and they built a second layer of APIs that are intended for developers to actually use. One of them, which is the simplest one to talk about, is the COM API, which is, you might have seen it from Lee Chagolia Christensen's post on getting a token. He talked about this in his blog post, but the COM API is the Proof of Possession Cookie Info Manager. It's a little misleading because it's talking about a POP token, but really, if you want any type of single sign-on cookie, whether Microsoft is calling it a POP token or calling it some other nomenclature, this will give it to you. So if you have a logon on a host and they've logged on to a Windows Live ID account, or they logged on with an Entra ID account, which is not really referred to by Microsoft as a POP token, this will give you all of those things. So it's kind of like this one funnel to get everywhere. You just say, hey, I have this logon ID, give me a token, and it'll talk to LSAS if needed, or the RPC interface is needed. It'll communicate to caches as well. It'll say like, hey, let me just check the cache first if needed. It's really smart in how it recovers the token for you. You may have seen something called the browser core application. It's what facilitates browsers to get tokens. Microsoft basically said, hey, Chrome and other things, they need tokens as well, but they may not want to talk with a COM API specifically. So let's give them this simple little application. They start it up, and it has an IPC mechanism it can talk to request tokens. That browser core app is directly built off of this COM API. So if you use the browser core app and you want something lower level, what you would use is the COM API. Now, this isn't the only second layer API that exists. Microsoft came up with something else called WAM, the Web Account Manager. The Web Account Manager is a little tricky to think about because usually with a component, it's succinct. You say, this component is an API or it's a service or something else. The WAM is two things. The WAM is a service called the Token Broker Service, and it is also an API. So it's these two large components that work with each other. So if you see the Token Broker Service, that is one part of the WAM. There is an internal undocumented WinRT API, which also is part of the WAM. And the Token Broker, sorry, the WinRT API is just complex. Unlike the COM API, where it's simple, the COM API just says, let me check the cache that is appropriate for this logon type, see if a token's there, and if not, let me ask the appropriate underlying API for a token and give that to the person. That's simple. That's what the COM API is. The WAM's WinRT API is not simple. It has its own plugin system. It has a plugin called Azure AD, which I did not misname that. They haven't removed the Azure AD name from the Windows source code. And that facilitates intra-ID logons and ADFS tokens. It also has a Microsoft account plugin. It also has weird things like a Xbox plugin if you do Xbox Live stuff. And there's also support for things like if Okta or Ping ever wanted to come out with their own plugin for WAM, they could do that, but I've never seen a third-party extension. Just saying that. So the WAM is something that its internal API is, again, undocumented. So what Microsoft did is they shoved another API on top of it called the Microsoft Authentication Library, which I believe you access from .NET. So what Microsoft actually intends you to do is talk to the MSAL API, and then that will get funneled into the WAM's mproc WinRT component, which will get funneled to some extension inside the WAM, which will get funneled to the appropriate cache to be checked, which will get funneled, if that doesn't facilitate the token, to the appropriate first layer API. I personally don't like the WAM. I think Microsoft has over-engineered a lot of things with cloud code. The WAM is a poster child of that happening. Okay, so this is a flow chart of how things are connected. We're going to dive into each different component. And then at the very end, we're going to come back to this. And we're going to say, now that you have a better understanding of these things, we're going to give you some guidance on if you're an operator or you're a researcher, what should you actually use? Cool. Oh, some things that we're not going to discuss, but you may be interested in is next generation crypto, which you should really check out Carrie's talk from Black Hat last year. It doesn't have tokens specifically, but it has a lot of other credential data to access cloud accounts, such as WebAuthn tokens and passkeys. So check out that talk. And some applications that Microsoft has developed have their own custom caches, aside from the two that you see on the screen, which is really annoying. They could have just use the same thing for everything, but they gave us more work, I guess. One example of this is the Teams application. They have their own cache. So that's just why. But if you want to see an example of that, Dr. Azure ID, Dr. Sunema, he has code on his GitHub as an example for recovering tokens from Teams. This is how I feel when I was making that slide. Hopefully you didn't feel this bad. But if you did, let's go into each different component. Let's start with the storage methods. This is the easiest to talk about. There's two, the Cloud AP cache and the token broker cache. The easiest to describe is the token broker cache. Let's start there. This is the offline cache for credential data, tokens, for Windows Live ID accounts, which again are the things like your Microsoft account, your work account, your school account. If you try to install Windows 11 nowadays, it's the account that they try to force you to set up before you even install the operating system. There's a good blog by my colleague Adam Chester, who wrote up, the blog name is Wham Bam, which describes this pretty well. But there's a storage location for on the file system for every user that logs in their local app data folder. In that one folder, there'll be a flat list of files. There's a possibility for a lot of different file types in there. There's a possibility for it to store things like a picture for your account, some things related to requesting tokens, that sort of thing. Personally, and these will all have their own little extensions, so they'll be like the extension .tbres. Personally, I have only seen the .tbres extension in these directories, and I asked my colleagues and they said the same thing. So you're likely only going to see tbres. That stands for the token broker result. So like the token broker code at some point requested a token to get the result. That result has a token shoved inside of it, and it's stored in one of these files. It's pretty simple. It's a JSON blob. If you open that file, it's plain text. Inside that JSON blob, there's a little blob of DPAPI encrypted data. You impersonate that user, decrypt the DPAPI data, and inside of that is going to be embedded a token that you can use. Now, it has its own serialization scheme for that token. The easiest way to get it out is to dump it to the screen. You're going to see a lot of stuff that is not human readable. And inside of that, you'll see a human readable token that you can shove into a browser. Easy enough for me. I'm lazy, that works. But if you are a developer and you really want to systematically recover these tokens and understand that encoding scheme, Dr. Azure ID, Dr. Sunema, he also has code on his GitHub to do that. So just search around his GitHub account and you'll find it. So that's simple. Flat file system, dump out some DPAPI encrypted stuff, you get some tokens. The other cache for the Cloud AP authentication package, which supports you being able to log into your host with one of these cloud-based accounts, it's not straightforward, just being honest. It has two places where it stores data, one on the file system, again in local app data, but this is only going to exist for the system user. So you have to impersonate system, go into its local app data folder, and then you'll see this Cloud AP cache. There's going to be some weird looking identifiers in that folder that isn't really going to make sense without additional context. That context comes in the form of metadata that exists in the registry. So you also have to look in this registry location to pick out some information to say, this random looking ID, that's user John. And I care about user John, so I'm going to go into that folder to get his credentials. Another way this is made a little more complex is there's a file, which we'll talk about, in this set of folder, in this hierarchy of folders. And this one file has the credential data for a user. It has things like anything you can imagine for a cloud account. So it has things for like their PRT if there's no TPM, their session key for the PRT if there's no TPM. If you do things with ADFS, those tokens are shoved in there. If you heard of Cloud TGT, which I don't even know how to use that, but if you have, that's also shoved in this file. So this is like a gold mine for a researcher. Like you don't have to think about how to acquire all these credentials. You just figure out how to decrypt this one file, and then you have all of it. But that blob of credential data, another reason this is more complex is that blob is encrypted. There's copies of it, and each copy is encrypted in a different way depending on how you have set up being able to log into your host. So if your account is able to log in with a password and a PIN and a passkey, there's going to be 3 copies of the data, and there's going to be 3 different encryption schemes. One that will allow one of the nodes to be decrypted with a password, one of the nodes to be decrypted with a PIN, one of the nodes to be decrypted with a passkey. So that's a pain in the butt, but opportunity for finding crypto bugs if you're into that. Here are all the different encryption methods. Login methods that are supported with different encryption schemes for this credential data. They have different numbers. I'm sure inside of Microsoft, they have an enumerator that just like defines what these things are. This is what we figured out. 2 of these, we still don't know what they are. Of these are the ones that we know how to decrypt. So the talk that I highlight on the slide from Troopers last year, it was amazing. You should go watch it. They described decrypting offline credential data that was encrypted using a password or a PIN. In the LSA Whisperer source code, you'll also see an example of how to decrypt with RSO or T-ball data. What that is when you turn off your laptop, sometimes Windows will cache some cred data in the registry to allow when you reboot the system, a Windows update to occur. Like it needs to log you into the host with that credential data that's stored in the registry. That is called the ASRO or T-ball data. And you can also decrypt some of this cred data in the file system with that. It's a very similar encryption scheme to how password encrypted data is done. So it made that effort a lot easier to figure out, thank God. Okay. I said there was a nested folder structure for the Cloud AP cache. Here's kind of what it looks like. So if you used LSA Whisperer tool, there's an extension module now to kind of give insight into the Cloud AP cache. It has a command called the config command. It will show you kind of the hierarchy of all this data on the file system. There's one folder for each Cloud AP plugin. So you'll see one for Azure AD, you'll see one for Microsoft accounts. Inside of that, you'll see these random identifiers. Each one of those random identifiers represents a different user account. And you have to go off to the registry to say, hey, registry, what does that ID mean? So you have to use that metadata to discern that the first random looking identifier is me, Evan McBroom. From the registry, you can also get data like what is this user account locally within whatever that cloud resource is, their SID. Subfolders of that include the cache folder, which is what contains that credential data that we're going after. There's the possibility for a second folder that I haven't seen anyone look at before, which is the keys folder. The keys folder is interesting because it stores Cloud AP plugin specific keys. So the data inside the keys folder is most likely going to look different for Intra ID accounts than if you looked at the keys folder for like a Microsoft account. So if you're into research, I highly recommend looking at those folders. You're probably going to find some useful cred data. Now, that cache folder has a single file inside of it. So you go to the user account folder, which is that random ID. You go to the cache folder, and inside of that, there's a cache data file. This is the gold mine. This is the one file that has those multiple copies of cred data. Let's look at how it's stored. It starts off simple. There's a version. It's going to be version 2 right now. Version 1 is what they were trying to figure out back in Windows 8, and they had the live SSP authentication package, which was thrown out the window. Now we have the Cloud AP authentication package, and they settled on version 2. So version 2 is what we're going to see. Let's check some just to see if it's been altered. That's fine. And you're going to see RPC serialized data. So again, the RPC subsystem can be used for defining interfaces as well as just serializing stuff. That serialization has been implemented into the development kit. So if you're interested in that, it's all there. If you deserialize that data, what do you get? You get some metadata that says, hey, here's what you're going to see inside this blob. And you're going to start seeing some nodes. You're going to see a different node of encrypted credential data for every single logon type that account supports. So as an example, you can see a node that's encrypted using a password if someone enabled password authentication. You're going to see another node for if someone enabled a PIN authentication. So on and so forth. You can have like 7 different of these nodes. I personally have always seen a password node, so that's going to be interesting if you want to decrypt some of this stuff. The nodes come in 2 parts. The first part at the bottom is the simplest to describe. It's going to be a blob of encrypted data, your encrypted credentials. Now I say that they're equal. What I mean by that is just it's used for the same purpose is what I mean by equals. But remember, they're encrypted differently based on how you logged in. Now, the second part of each node is going to be different. Remember, there's a different encryption scheme for each way you can log into the host. This second part of a node is like this special chunk of data that Microsoft said, hey, developers, use it however you need for whatever encryption scheme that you're implementing. So it's going to look different for if you're looking at the password node. It's going to be this blob of data called a secret, which is encrypted with a password. So you decrypt that blob first, the blue blob, and then you get the secret, and then you can use that secret to decrypt the green blob. That's the encryption scheme for the password. It's going to look different than the PIN blob. So if you look at the PIN node, the blue blob is different. It's a structure that's really complex. There's a lot of stuff in there. And honestly, you have to decrypt like 2 or 3 different things. If you want to look at that, please look at the Troopers talk from Synactive back last year. It goes into that in depth. They did a really good job on it. But this is kind of what the structure looks like for this file. If you are successful in decrypting the green part of these nodes, you're going to get 2 things. You're going to get a credential key, which is used for cloud-based accounts to decrypt DPAPI data. You're also going to get a JSON blob, which has that plethora of all the cloud-based credential data you would ever want. So if there's a cloud TGT that account has, it's going to be in there. If there's a PRT or a session key without a TPM on that host, you're going to have it in there. If there's anything to do with ADFS, it's going to be in there. The only thing that's kind of a pain in the butt with this is, other than brute forcing a PIN for a host without a TPM, the only public way we're aware of to decrypt this data is by knowing the user credential data. So knowing their password, knowing their PIN. So this is incredibly valuable for researchers. I encourage you to go find your favorite tool to get this data if you're a researcher. If you're an operator, it may not be the best because you will have to have knowledge. As far as I'm aware, you would have to have knowledge of user credential data to even get this. Okay, that's the storage mechanisms. Let's talk about these first level APIs. You got 2, the Cloud IP authentication package calls, and then you have that RPC interface. The Cloud IP authentication package call is the simplest for me to describe. Essentially, you have your own program, your own application. You want to make one of these requests. You use a well-documented Windows API called the LSA Call Authentication Package API. You submit a blob of data. The blob of data you want to submit is a Cloud AP message that is not documented, but it's in the LSA Whisperer source code, so you can go after that. The specific message you submit is something called call plugin generic. That's the outer wrapper that you see on the screen. So you see my cursor. This outer wrapper is that generic message that allows you to embed an internal message intended for a sub plugin. In that internal message, you can submit commands to each of these plugins. Some of these commands we documented last year, specifically for the Azure AD plugin. So in LSA Whisperer, from the code last year, you can call a bunch of commands. The ones of interest here are those 3 commands for getting a token. They can put in a browser for a normal user, for the device. If you do stuff with ADFS, that's the enterprise command. Can we turn the lights off? Whoever turned them back on? Thanks, Greg. But there was something else. There was another plugin, the Microsoft account plugin. Can we get the lights off, please? You guys keep working on the lights. I'll keep going. Thank you. So last year, one of the things that we couldn't solve is how to submit these commands to the Microsoft account plugin. This is useful because if you want a token for cloud stuff for someone who logged in with like a Windows Live ID account, so a work account, a school account, you would want to submit a command to this plugin. We couldn't figure it out. There was extra serialization data. We just couldn't solve it. But with these private symbols, it just illuminated how to do it. So we came back to this problem and we solved it. There's a single command you can submit to this plugin, get signed proof of possession token. That's implemented in LSA Whisperer. You just submit that command, you get a POP token. You can log in to authenticate to cloud-based services as a work, school account, that sort of thing. So again, if you want to see code, it's in the LSA Whisperer source code. The other API is that RPC interface that I refer to as the Windows Live ID RPC interface. I have a little warning emoji here, and the reason I have that is RPC interfaces, once they start being used by developers, you're not supposed to change them. That's like a golden rule, or at least if you change them, change it in a way that doesn't break anything. Microsoft hasn't, this is a rule that Microsoft came up with, and they haven't abided by it for this one interface. It has changed at least a few times in Windows 10. It changed again in Windows 11. It's a pain in the ass to keep up with and keep a stable client for. That being said, there's two ways to interact with it. You can have a normal RPC client. That's what's in the LSA Whisperer source code. After I implemented that, I would say I do not recommend that approach because the interface keeps changing. And if you work at Microsoft, please tell your developers, stop changing RPC interfaces in a way that breaks them. It's not a design goal for that technology. Just learn your own stuff. When you do that, there's a lot of operations you can call. There's 87 something. There's another one for Windows 11, so 88. The one that is the most useful, it has a star next to it. Get open handles data. Essentially, with this RPC interface, what you can do is you can enumerate on that host everyone that's logged into an application. So you can say John or Bob or Alice, they're logged into Word applications or Outlook or whatever. You can see that from this RPC interface. And then you can pick out one of those users and you can say, open that handles data for John or Alice or Bob. And then once you have that, you get this context and you can use that context to get tokens for them. So that one star thing is what you should seek out implement red team tools for. You can get this context from that RPC operation to then start getting tokens for users. Okay. There's another way to interact with this RPC interface. There's a module in System 32 called the Windows Live ID Client DLL. It has exports for each one of these operations. I highly recommend basing your tools off of this module instead of directly implementing an RPC client. And the only reason for that is I would hope Microsoft does not break their own library. They're breaking their RPC interface, but I have hope this Windows Live ID client library will stay stable. So that's what I would recommend you use. One last thing to talk about before we go back to our original question. The APIs that were built on top of all of this. So you got two. You got a COM API on the left called the Proof of Possession Cookie Info Manager. And you got a WinRT API on the right, which is one of the two parts of the WAM. They're both inside your own process. So if you use one of these APIs, a DLL will be loaded in your process to support that. The COM API is documented by Microsoft. That's nice. The WinRT one is considered internal. It's not documented, which is a pain in the butt. And that's because they really want you to use the even higher level API, the MSAL API. Okay. You're probably familiar with some of these because the COM API supports that browser core application. And then the WinRT one supports the MSAL API. I personally recommend the COM one because if you look at it in Ghidra, it's way simpler. There's no extension design. It's just see what your count type is, check the appropriate cache. If the token is not in the cache, make a new one. Simple. The WAM is not simple. It has all these extensions that could exist, and it goes through all of them. It's like this weird flow. So I highly recommend using the COM API. And if you want code for this, There is, it's not in LSA Whisperer, but there is code online on GitHub. So these are tools that we use at work. There's one from Lee at the top, which is, if I remember right, C++ and .NET code for interacting with the COM API. There's also a BOF, a beacon object file as well, the second tool. And then on the right, my coworker Daniel has a, I believe, .NET project for interacting with MSAL. So if you want code, those are good references. Okay, let's go back to that original flowchart. We had this whole talk. Hopefully we can answer this question. Of all these things, what do I use? Okay. Now, as a good consultant would say, it depends. It depends on who you are. If you're a normal application developer, please use MSAL, the Microsoft Authentication Library. It's what Microsoft is going to support for long term. It's what they are pushing people to use. It's well documented. It's documented across platforms. So if you get used to using this on Windows, you can use it on Android or other platforms. Now, if you're a red team tool developer, use this COM API. It has all the features you're going to want. It figures out your account type. It figures out stuff that's in the cache. It figures out, do I need to request a new token? It's easy. Don't stop there, though. Also use the Windows Live ID RPC interface. There's a ton of credential data we didn't even talk about. We were talking about tokens. But in this RPC interface, it has things for TOTP data, like other credential data for cloud-based accounts that you would be interested in. It's all in those 88 now operations on Windows 11. So please dive into that RPC interface. But don't write your own RPC client for it. I had this notation here in this little box to use the Windows Live ID CLI DLL. So the Windows Live ID client library. Please, if you can, use that DLL because Microsoft has not, they have forgotten the lifelong lesson of do not break your RPC interface. They keep breaking it. It's not fun. If you use the LSA Whisperer tool, you'll find that it works on an up-to-date Windows 10 host. You use it on Windows 11, and the Windows Live ID support we have does not work yet because the RPC interface keeps breaking. Now, if you're a researcher, the last one, use everything on the right, the lower level APIs, as well as the caches. And the reason I say that is this gets you the closest to the ground truth of whatever you're researching. You want to have solid facts about, I got this token from this technology to base further conclusions on top of. So use those lower level APIs, but also use these caches. The Cloud AP cache, it has every credential data you could ever imagine. And you can, as a researcher, you can actually access it because you would know that password. You would know that PIN, so you can decrypt it. So that's what I would recommend. So if you have different hats, you're going to use different APIs, but this is ultimately what I arrived at. Okay, to wrap things up before we get to that present that I mentioned at the end, we added a lot of code to the LSA Whisperer tool to support all this work. The code currently exists in a branch, version 3.0. It's not in the master or main branch. The reason for that is there's some stuff that's unstable on Windows 11 that we're working out. It's stable on Windows 10. But some of the stuff we added, you have that development kit. I mentioned if you're a reverse engineer, even if you don't use this tool, please look at the development kit. If you're a reverse engineer, you're going to find, I almost guarantee you, anything that has historically been reverse engineered in this industry related to credential recovery on Windows is either already in this development kit because it was leaked in those private symbols, or it could be added again from those private symbols. So stuff like the structure of the Windows Vault, as an example. We've reverse engineered that as an industry, but it just exists in these private symbols, and now it's in the development kit. So save yourself some time if you're a reverse engineer, please. We've added code for interacting with the Microsoft account plugin, which was a personal joy for me because it was a future work item from last year, and we're actually able to solve it this year. We also added support for extensions inside the tool to help support some of these related tradecraft for recovering credential data. You have extensions for working with that Cloud AP cache, decrypting it, and this is online decryption. So you have to have a currently running host to do it. You have to know the password, you have to know the PIN. If you want offline decryption, please look at the code from these Synactive researchers from that Troopers talk last year. They have code for offline decryption as well, which is pretty wicked. You have stuff for just quality of life support for interacting with your current token for your process, just helps use the tool overall, and stuff for interacting with that Windows Live ID RPC interface. Works on Windows 10. We're going to hopefully get it working for Windows 11. If you write your own tool for that RPC interface, please use that Windows Live ID client library. Last, there was a lot of wiki updates. You're not going to see the wiki updates yet if you like browse through the actual wiki in GitHub, but there's a lot of documentation updates that exist in branch 3.0. So just go through the actual source code for branch 3.0. There's a wiki folder. You'll see all the updates in there. There's one more thing, the present. Thank you for sticking around. Last year, when we released this, we released the tool as a research tool. That was our goal, just to help ourselves and other people understand all these technologies so we could be better operators. We could write follow-on tools. But within that year, there were some things that were added, a lot of things that weren't. So we felt that to progress the industry, it would be best to have stuff you can actually operationally use. Beacon object files, they have people who like them, don't like them, but they're what the industry uses. That's what we settled on. And that's what we added. Now, I'm going to say up front, these are all experimental beacon object files right now. The reason I say that is there's a lot of different C2 platforms that support various features of a beacon object file. Some of them support exceptions, some of them don't, some of them break half the time if you compile with one compiler versus MGW. So that's why I say they're experimental. Half of these have been tested very well, half of them are not. When version 3.0 gets merged into main, these will all be tested, but the code exists on GitHub right now. So you at least have almost everything at least in my tested form. So what do you got? You got stuff for gathering information from a host. The one that was a personal joy for me to get working was the very first one, DSR CLI. If you've been on a red team and you want to see, hey, is my host joined to Intra in some form? You've probably used a command called dsregcmd if you were okay with running a command line tool. You probably have used this before to say dsregcmd status. That DLL that supports that tool has one export that you can call to process all your command line arguments. We just shove support for that one export into a buff to help with your cloud tradecraft. So, and that one has been fully tested. So you should be able, as long as your buff tooling works well, you should be able to use this buff. The other stuff that was helpful for us is things to get information about your current logon session and other logon sessions, current configuration data for the host. The config data stuff is stuff that still needs to be tested a little more, but the rest is good. You got stuff for recovering credentials. So things like if you logged on with a local account or a Kerberos account, there's this thing called a credential key that we talked about last year that you can use to decrypt any DPAPI data for a user. That's supported in the tool. We now have a buff for it, which is pretty fun. So if you do DPAPI stuff, get that. The cloud stuff still needs to be tested a little more, but one that has been tested really well is get NTLM v1 response. I know I'm running short on time. I'll be quick. This is the last slide. Get NTLM v1 response is particularly special for me. It's something that has not gone away from Windows. Windows, if you look at the recent operating system update page, the releases page, where they say like, here's stuff we added, here's stuff we removed. They have a note on there that they have, I believe, completely removed NTLM v1 from the most recent update of Windows 11 and Server 2025. That's a lie. It's a marketing trick from them. It is not true. I submitted an MSRC report to them and said, hey, you said you removed NTLM v1 response generation from Windows. It's still there. I can still use it. I just double click this LSA Whisperer tool, say, give me it, and it gives me it, And they said, oh, we don't think this is a bug. They also asked for a video for me to walk through it, which is a pain. I'm not going to do their work for them. They eventually said, we're not going to fix this. So it's going to be here for a long term. But they were annoying enough to ask for these slides, even though they're not going to do their own job. So if you want one thing that's particularly interesting, use the get NTLM v1 response buff. If you're unfamiliar with that, the reason it's impactful is if you get an NTLM v1 response, you can easily crack it into an NT hash you use for pass to hash. Easily, right? But if you control one piece of input data, you can use a rainbow table to instantly get an NT hash. Now, this one API allows you to supply that input data. It's called the challenge. So you use this BOF, you say, I have a challenge of 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 8. And it gives you an output that you can plug into a rainbow table, instantly get an NT hash, and instantly do pass to hash tradecraft. So please go use that and get Microsoft to actually remove this from Windows in 10 years. The last bit, and then I'll get off. We have some stuff for miscellaneous tradecraft that the first one has been fully tested because it was simple. The other two were still testing. But the reason we find this interesting is a lot of people want to load extra code into LSAS. An easy way is to load an extra SSP. We have purge tickets on there. Purge tickets is something that you see in a lot of stuff. One personal project that I really like on GitHub is called the Nano Rubius project. It's a collection of buffs for dealing with Kerberos. So you've probably seen tools for purging tickets. One thing you can do with purging tickets is you can selectively purge a ticket. You can say like, hey, I have 10 tickets in my cache. I don't want to remove all my tickets. I just want that one ticket to be gone. All these red team tools support just clearing out the whole cache, but that's a tool-based limitation. That's not a technology-based limitation. The technology actually allows you to pick and choose which tickets you want to remove. So that's supported in LSA Whisperer proper. In the buff, we're still testing, but we'll eventually have a stable buff where you can remove specific tickets from your cache, which will just help with operator quality of life. The last one is a transfer creds buff, where you basically say, I have 2 logon sessions. I want to take all the creds from this logon session, shove it into this other logon session that I control so I can do my tradecraft. So I haven't seen that abused in red team tradecraft, but I feel like it's going to come up in following years. People pick it up. So that's it. I'm definitely running close on time. I don't think there's any questions, like time for questions, but please grab me afterwards. Up next, we have Carrie, who is a talker that I really enjoy, so I'm looking forward to your talk. Thank you, guys.